So when we transmit the bits from one place to other place, when we send some data using some hardware, then what happens is, because of, sometimes it might happen because of the errors in the hardware or because of the disturbances from outside, some of the bits might get changed, and because of that you might see a different information at the other side than the information that you are sending. So this is called as error. So error while transmitting, or sometimes you need not transmit the bits, you might try to store the bits in a hardware device like our memory, and later if you try to fetch it from our memory, because of the errors in the hardware you might get a different data, which means some of the bits might get changed. They are called bit errors. Now what are the various ways to handle it? That is called as error handling. So if you have any errors, there are generally two ways to handle it. Error handling methods, there are generally two. So one is error detection and the other one is error correction. So what do I mean by detection is, you know that there is an error in the information and you don't know where the error is. So if that is the case, then that is called error detection. And error correction is, you will know that there is error in the data, as well as you know where the error is, and so you can correct it. That is called as error correcting mechanisms. Therefore we have various mechanisms. One is error detection and other is error correction, and under this we have various mechanisms. Now first of all, let's see what are the basic properties that are required in a code. Whatever code you are using, what are the basic properties required in that, so that the code will be suitable for error correction or error detection. See this. Now let us say you wanted to send 0 in 4 bits, 0 0 0 0. This is what you are trying to send. Now during the transmission, because of 1 bit error, let us say it got converted, this bit got corrupted from 0 to 1, and because of that 1 bit error the receiver has received 0 0 0 1. Now receiver will think that yes, 1 is the information that you have sent, 0 0 0 1 is 1. He will think that 1 is information that you have sent. Actually what is information that you sent? 4 0, but what is he received? 1, but he thinks that it is the right information. Why do you think that this one has happened? Because let us say this is BCD. In BCD, both this code 0000, this pattern, and 0001, both are valid. Therefore when there is an error, and if that error is changing the bits or the pattern from one valid pattern to the other valid pattern, then it is impossible to detect that error. Again, if the error is changing the code from one pattern to the other pattern, right, and if both the patterns are valid, then it is impossible to detect such an error. So for example, if you are having the number 0000, and if you are trying to change, if you are sending it and if it got corrupted to, let us say 1100 in BCD, then you can easily detect the error. The reason is, this is a valid code, right, and it represents 0, but if the receiver has received 1100, it is 12, right, and 12 is not there in BCD. If the receiver knows that BCD numbers are being sent, and now if you are sending this one and if he receives this one, he can find out that since this is not a valid code in BCD, I know it could be an error. Therefore only way that a receiver can find out that there is an error in the code is if he knows that there is if he sees that he got a invalid code. Therefore what we should do is, depending on your requirement, in our code we should have both the valid codes, valid patterns, as well as invalid patterns. Now if there is any error, if that pattern, valid pattern, changes to invalid pattern, then the receiver can understand that, oh, there is an error. I'll just tell you one example. Okay, and this is what, okay. Now what is the problem with or let's see error detection. So error detection is various. We have to talk about this based on the number of bits that might get corrupted. Let us say we want to discuss about detecting the error in case of 1 bit errors. Okay. Now let us say we have a data like this. And now if I get 1 bit error, then this pattern will get changed to some other pattern, right? Let's say this one. Okay, now whatever pattern you got here, it should not be valid. If this is valid pattern, then we may think that there is no error. Therefore, in order to detect 1 bit error, the distance between every two valid patterns should at least be 1, should at least be 2 here, sorry. From here to here, the distance should be 1, which means if any bit here gets corrupted, it should take it to a other pattern, and those patterns should be invalid, right? And similarly, if there is any error here, it should take it to some other pattern. Therefore, in order to detect 1 bit errors, the distance between every two valid codes should be at least 2. Got it? So if you didn't understand here, I'll just take an example and I'll show you how the error detection. Let us say the question is like this. We are using a code in which the patterns used are like this: 0 0 0 0 0 0 0 1 1 0 0 1 1 1 0 0, right? So can this pattern be used in such a way that it will detect the 1 bit error? It will detect 1 bit error. So can we detect 1 bit error here? So if that has to be used, the distance between every two valid patterns should be 2 at least. So now the question is, can these patterns be used in order to detect 1 bit error, right? If these patterns has to be used to detect 1 bit error, the distance between every two codes should be at least 2. Now check this, the distance between these two is not 2, the distance between it is 1, therefore it cannot be used for single bit detection, single bit error detection. The reason is simple: if 1 bit error happens here, then there is a chance that that one single bit error might happen here, there is a chance, right? And then it might get converted to this 0 0 0 1. Now there is no way we can find out that there is a error here because both are valid. So this code is not suitable for single bit detection. Now let us say we have one more code like this: 0 0 and then 0 1 0 1 0 0 0 0 1 1 0 1 0 1. Okay, let's say these are the codes used. Now the question is, can these codes be used in order to detect 1 bit error? So what is the condition? If it has to detect 1 bit error, the minimum distance between every two valid codes should be at least 2. Let's see what is the distance between these two. The distance between these two is 2 because 2 bits have to be changed to get this, right? What is the distance between these two? The distance between these two is also 2 because 2 bits have to be changed. Distance between these two, again it has to be 2 because 2 bits have to be changed, right? Similarly, so we have compared this one with all the other 3 and the distance turned out to be 2, right? And we have to compare this one with these two. So check these two. The distance between these is also 2, and check between these two. The distance between these two is also 2, right? So where? Here and here. So even this one is at 2 distance from all the other. Now check the distance between these two. The distance between these two is also 2. Therefore, now if we observe this 4, we have found out that the distance between every pair of valid codes is at least 2. Therefore, if there is 1 bit error, that will definitely take any combination to some other combination which is not valid. Therefore, we can say that this particular code can be used for single bit representation, but then single bit error detection, but then it can represent only 4 things, right? It can represent, if you are using it to represent numbers, it can represent only 0 1 2 3. So we have to have a lot of codes, but I'm just taking a small code as an example. So if you understood this, just try to see this. Let's see what happens if there is a single bit error for this one. If there is a single bit error for this one, then it might take it to either 1000 or 0100 or 0010 or 0001. So this one might become any one of these because of single bit error. Now if you check it, these four are not there. These four are not valid. So if a single bit error happens here, that can easily be detected because all the bit patterns which you get are all invalid according to this code, because these are only the codes which are valid according to us, and whatever we get other than this are invalid. Therefore any single bit error for this one can be detected. Similarly we can do the same here. If a single bit error happens here, what happens to this? It will become 1011 or 0111 or 0001 or 0010, right? Again all these are invalid. Similarly you can see what happens for a single bit error for this, single bit error for this. Therefore what I mean to say is, if the distance between two valid codes is at least 2, it will be able to detect 1 bit error. So similarly on the same grounds, can you just guess what should be the distance between two valid codes so that it will be able to detect 2-bit error? Check this. Now let us say we have a valid code and we should be able to detect 2-bit error. What does it mean? Even if 2-bit errors happens, then it should not land up as a valid, or it should not get converted as a valid pattern or valid code, which means, see this, if 1-bit error happens, it should take us to an invalid code, and if one more bit error happens, then also it should take us to an invalid code. Therefore these two should not be valid, right? And then there should be one more valid code. If at all it is going to be present, it should be present at a distance of this. Therefore if you want the code to detect 2-bit errors, then even if 2-bit error happens to a code, it should take us to an invalid combination only. So what does it mean? The minimum distance between two valid codes in such a case should be at least 3. If it is greater than this, it is fine, but it should be at least 3. Are you getting this? What happens if the minimum distance between two valid codes is 2? Then you might end up here, right? So this happens to be a valid code, then 2-bit error is going to become a valid combination. It cannot be detected. Got it? Therefore in order to detect 1-bit error, the minimum distance should be 2, and in order to detect 2-bit errors, the minimum distance should be 3, isn't it? 1 2 3. The minimum distance between two valid codes should be 3, and in order to detect 3-bit errors, then you can guess it. So 1 2 3, even this one should be invalid, and valid code only can be present after that, beyond that. Therefore you are supposed to have 4. So one important question is, if your code has to detect t-bit errors, then definitely the distance between every two valid codes, the minimum distance between every two valid codes should be at least, so let me put it this way, should be greater than or equal to t plus 1, should be at least t plus 1. The reason is, if it is greater than that, it is fine. If it is greater than that, it is fine, but it should not be less than that. Got it? So remember this, it is very important point. This is how we can derive it. So the minimum distance between two codes, that is also called as Hamming distance. So what is the minimum distance between any two valid codes in a code is generally called as Hamming distance of the code. So the Hamming distance of the code has to be at least t plus 1, so that it acts as a error detecting code. Now let's see what happens with the error correction. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.